Vtvm like this one shown in the picture. These are really old and very useful equipment to servicing the radios and all tuners. So I have downloaded some data sheet from the internet and I was reading all through these, and they use the vacuum tube. Then I came across this type of meter. It says solid state utility voltmeter made by Kit, and I was looking for the better circuitry, and I have downloaded few of them. They use a FET instead of vacuum tube because FET also have the high input impedance. Some of them use op-amp like this one. Came across this beautiful document downloaded from internet, of course. This is constructional high impedance MOSFET voltmeter. It's quite easy, and the main thing is this microampere meters, and this is 0 to 100 microampere meter. This is my FET voltmeter, solid state voltmeter. Actually I was thinking to get a Vtvm vacuum tube voltmeter, but now these days vacuum tube are obsolete, and if I get them it would be very much pricey. So have found a different approach using solid state, and they are also working very good. So this is my DIY version of solid state voltmeter according to the schematic, using some high impedance JFET input op amps, and these all the parts are readily available in the market. So I have used this analog 100 microampere ampere meter, and this is the rotary encoder switch. This is the zero adjustment potentiometer, on off button, DC and AC different plug. Yeah, I have did a little bit of modification. I did some modification with this circuitry according to my requirement, and this metal box I have salvaged it from a wiring hardware store. These are available, and I have to purchase this metal sheet differently from a lathe, and I drill those holes, and it's working very good. I'm happy, and these markings use permanent marker, but in future I maybe will try to use some sticker or maybe use some printer kind of thing to look more nicer maybe. But right now I'm very much happy with this. This performance is really good. The AC probe, it shows like there is a ceramic filter and a BAT85 diode and a 4.7 ohm resistor across it. So I have collected bunch of register. I don't have BAT 85, and this is a Scotchy diode, so I will use this one instead. This is 1N5819, I guess. So anyways, let's open it and calibrate the AC measurement range. So this is the full setup of my Vtvm solid state voltmeter. Let me explain some of this connection according to my schematic. Here comes the power. This is the AC input line from the AC socket. And this is the DC socket, and the DC socket goes through this 1M register to that rotary encoder input, and this 101 is from the AC output from there. And this is the voltage divider. I have used 1K potentiometer for the zero adjustment, and I have used 4K7 to 4K7 across it to make it more accurate. And this is all together. I've tried to use all MFR 1% register and selection switch. Almost drawing 10 milliampere. So let's compare it, measure some voltages. I have a brand new 9-volt battery. So .69 volt this battery. Now this is on. Measuring the DC. .50 volt for division. So each segment is 10 volt, so it's showing 9 volt. I give it like 10 volt section. Full scale is 10 volt now. Nine point something voltage, more than 9 volt, as you can see. So DC measurement is quite okay. So now let's measure the AC voltage. Is 11, more than 11 volt. So now let's check it with my voltmeter. Plug into the AC. I have to increase because it is like 10 volt deviation fully scale. As I can see, that is 11 volts, so I can't use that. 50 volt. Let's see now. $50. Each segment is 10 volt, so 11 volt, more than 11 volt. So AC measurement is also very accurate.